Now let's see the advanced data and information systems that can be used for data mining. Here we have object relational databases, temporal, sequence and time series databases, then spatial and spatio-temporal databases, text and multimedia databases, heterogeneous and legacy databases, data streams and World Wide Web. You just listen to the session, but you may not understand all the concepts I am going through with this session. But this is just for your information. Actually, this is not included in your syllabus as such, but we should know these kinds of data, and we have to be aware of this when we move on to the advanced topics on data mining. So just listen to this session and try to understand these are different types of data that can be used for data mining, and we will discuss each and every point in a systematic manner. So these systems require sophisticated facilities to efficiently store, retrieve and update large amounts of complex data. So many challenging research and implementation issues are still going on. We can't say it is a matured technology. It is still developing, and many of these data types are not fully satisfied with the process of data mining. So we can develop the mechanisms for analyzing on these kinds of data. Okay. First one is object relational databases. Techniques need to be developed. Still, the techniques are not enough. We need to develop and for handling complex nature of object relational systems. The next one is temporal, sequence and time series databases. This is also another kind of data that can be used for mining. Data mining techniques can be used to find the characteristics of object evolution or the trend of changes for objects in the database. This deals with the time series data, which can be considered as stock exchange data. So, for example, stock exchange data can be mined to uncover trends that would help you plan investment strategies. When is the best time to purchase a stock and all. So, for this we can do the data mining, and this kind of data is known as temporal, sequence and time series database. And the next one is spatial and spatio-temporal databases. Data mining on spatial databases can be performed to find the relationship among a set of spatial objects. For example, any data related to space can be considered as spatial data. To discover which subsets of objects are spatially autocorrelated or associated, we need to understand some functionalities of data mining, including clustering and outlier analysis, that we will discuss along with the functionalities. But just for the completeness, I am just discussing here. Clusters and outliers can be identified by spatial cluster analysis. Example, if we want to describe the climate of mountainous areas located at various altitudes, we can use that particular spatial data for the purpose of data mining. Next one is text and multimedia databases. If we mine something on text, we are calling it as text mining, that I have already discussed with you. So we will see how the text and multimedia databases are utilized in this particular mining. Okay, data mining on text databases may uncover general and concise descriptions of the text documents, keyword or content associations, as well as the clustering behavior of the text objects. to do the text and multimedia mining, information retrieval techniques need to be integrated with standard data mining methods. Let's see, for text mining, we have to use some hierarchies specifically for text data, such as dictionaries and thesauruses. It will help the text mining in a better way. It uses discipline-oriented term classification systems such as in biochemistry, medicine, law, or economics. For example, we want to mine something from a doctor's prescription. It is a example for text data. So we can do some extractions, do some knowledge discovery from this kind of prescription. So we need some additional terms that is included in the medical field. So medical terms will be there. So it will help this text mining. And next one, for multimedia mining, it includes construction of multimedia data cubes, the extraction of multiple features from multimedia data, and similarity based pattern matching. So this is the case of multimedia data. Next one is heterogeneous and legacy databases. Heterogeneous means we have to collect data from different sources here, and it may be of different format. For example, we want to know student academic performance among different colleges. In each and every college, they may be following different mechanisms for grading the students. So these kinds of databases can be used for the purpose of mining. Information exchange across these databases is difficult because it would require precise transformation rule from one representation to another, considering diverse semantics. DM techniques provide solution to the information exchange problem by performing two types of operations. One is statistical data distribution and correlation analysis. Using these techniques, it transforms given data into higher, more generalized conceptual levels. We can grade into higher level, or it can be in a generalized form, such as fair, good, excellent for student grades based on the marks or something. Okay, this is the kind of data that can be used for. Next one is data streams. We all are aware that we may notice that we are under video surveillance, like that. So this kind of data is known as data streams. So it is an example: video surveillance data, sensor data, weather or environment monitoring data, network traffic data, etc. Normally, these kinds of data are not stored in any kind of data repository. We are just streaming the data, but we are not storing it in a permanent method. Sometimes it will remain for 1 day or 1 week. After that, it will erase the data. That is the normal method. Therefore, effective and efficient management and analysis of stream data poses great challenges to researchers. The data mining on this streaming data is very difficult and it is challenging. A typical query model in such system is continuous query model. We have to use some continuous query model for processing the data mining on this kind of data. Using this predefined queries, constantly evaluate incoming streams, collect aggregate data, report the current status of data streams, and respond to their changes. This can be done through predefined queries. For example, to detect intrusions of a computer network based on the anomaly of message flow, you can identify the intrusions in a computer network based on the anomaly of message flow, that is, some changes in the message flow. This can be discovered by clustering data streams or by dynamic construction of stream models, or comparing the current frequent patterns with that at a certain previous time. So these are the possible ways we can detect the intrusion of a computer network. Next one is World Wide Web. This is one of the largest kind of data that can be used for the data mining. It is difficult to understand the semantic meaning of diverse web pages and structure them in an organized way for systematic information retrieval and data mining. For example, in normal case, web search based on a single keyword may return hundreds of web page pointers containing the keyword, mostly not needed to the user. So this is the normal. And data mining can provide web services such as or authoritative web page analysis can be done, and automated web page clustering and classification can be done. Then web community analysis also possible using data mining. For example, what do you mean by authoritative web page analysis? It will help rank web pages based on their importance, influence and topics. Automated web page clustering and classification will help group and arrange web pages in a multi-dimensional manner based on their contents. And web community analysis will help identify hidden web social networks and communities and observe their evaluation. So these are the different web services that can be done using data mining. So this is when we consider web data or worldwide web data for data mining, we can call it as web mining. So web mining is the development of scalable and effective web data analysis and mining methods. It may help us learn about the distribution information on the web in general, characterize and classify web pages, uncover web dynamics and associations among different web pages, users, communities and web-based activities. So this comes to the end of the advanced types of data that can be done, that can be used for data mining. Thank you.